What we're trying to do long term is to develop structures that will assemble in edible oils, things like fish oil or flaxseed oil or canola oil. And the reason we want to do that is, although those oils are really good for us, they lack a lot of the physical attributes that are desirable when you actually begin to process these food ingredients into ultra processed foods. Foods that rely on fat structure like chocolate, cocoa butter, things like that have a lot of saturated fat, or they have a lot of industrially produced fats through hydrogenation. So what we look at is trying to understand if we can use other molecules other than saturated and trans fats that will crystallize, self-assemble into a network. We don't understand what drives some molecules to come together and what allows molecules to remain dissolved. So what we're trying to do is get to the molecular level of coding required that drives self-assembly. Very focused light in the Brockhaus line or in any of the CLS beam lines. The idea is to actually try to solve the structure of the molecular arrangement or the unit cell of these molecules to get a better understanding of the actual interactions that drive their growth. So we've mainly focused on using these materials as saturated fat replacers, but there's a lot of other applications outside of the food industry. For example, these are phase selective sorbents. So if oil is spilled in the ocean, these materials can actually be used to reclaim and absorb oil, but not absorb the water. And they can then actually be extracted a lot more easy from the surface of the water and prevent spread. They can be used in biomaterials to grow cells. Depending on what the starting molecule is, if it's a sugar or carbohydrate, there's a lot of really interesting applications. This system that's behind us is a compound that contains ceramides as well. And one of the really interesting things with ceramides is it's essential in forming a healthy dermal layer. They can actually be a scaffold to allow new tissue regeneration. So in someone that has suffered a burn, the network that forms here could actually be a stimulant to grow new skin cells over that burned area. With this research, what we can do is build that library of information to identify new molecules, removing the research field's reliance on serendipitous discovery. And by creating a priori tools, we can actually move into rational design where we know the molecular coding for these molecules, which will actually drive them to self-assemble.